So hello everyone, good morning. Good morning. Sorry for the 5 minutes delay. Good morning, good morning, good morning. So this is the last class on gradient and divergence. So if you haven't watched the previous 5 videos, go through that. So this is the last class on gradient and divergence, right? Okay. So far in gradient, divergence and curl, what we have seen, right? So far what we have seen is we have seen the very first class we have given the overview of vector analysis. So after that we have discussed the last 10 years question papers. We have classified the entire syllabus of vector analysis into some 6 parts. The first part is gradient, divergence and curl. So after that we have some curves in space, Tarsian, and then a line integral, surface integral, volume integral, and then the 3 important theorem, Gauss divergence theorem, Green's theorem, and Stokes theorem. This is what we have classified the syllabus. Now we are in, we have started the first topic. Now we are going to complete the first topic, which is gradient, divergence, and curl. So in the very first class, we have defined what's meant by gradient. We have solved some problem on that. And then we can find the gradient for a scalar point function, but the gradient is a vector point function. Then we have defined what's meant by level surfaces, and then we have found the equation of tangent plane and normal line to the level surfaces, and then we also found the angle between the two surfaces, right? Angle between the two surfaces. The formula is cos theta is equal to angle between the two surfaces is the angle between the normals, or you can use the formula cos theta is equal to del phi 1 dot del phi 2 at the given point divided by modulus of del phi 1 into modulus of del phi 2, right? And then we have introduced the definition of divergence. Divergence and a vector is said to be solenoidal if divergence of the vector is 0. And we have defined what is meant by curl. And if curl is 0, then we say that vector is irrotational, right? And then we have solved some problems based on that. And then we have introduced vector identities, right? So there are 11 identities that we have put in the previous class. Now some more little bit of part, right? Little bit of part is missing. So I finished that, right? So maximum I think I can finish in 30 to 40 minutes. This is the last class, right? On gradient divergence curl. Okay. So we'll start. So first we will start with the basic problem just to refresh yourself, right? Just to refresh yourself, you will start with the basic problem, and then we will introduce one new concept. Okay. Okay, so we do this. So we'll start today's session. We're going to learn a new concept today. So before that, we will just to refresh, we will do a basic problem. So some problems, right? First problem is find del phi. Find del phi if phi is equal to x square plus y square plus z square into e power minus x square plus y square plus z square whole power 1 by 2, right? Okay. Now we need to find gradient of this phi. They have given phi. This is a scalar point function, right? So very simple. So what is the formula? So del phi. So del phi is dou phi by dou x I vector plus dou phi by dou y j vector dou phi by dou z into k vector, right? Now what I'm going to do is it is very difficult, right? It is not difficult. It will take time to differentiate this entire term with respect to x, right? You need to apply UV method, and then you will differentiate with respect to y with respect to z, right? So it will take time. So instead of that, what I'm going to do is, right, you can do this also, right? You just have to differentiate this entire function with respect to x. So you apply product rule, you can get the result. So to make it more easier, what I'm going to do is, so we know that if r vector is equal to xi plus yj plus zk, we know that modulus of r, right? So modulus of r is root of x square plus y square plus z square. So that means r square will be x square plus y square plus z square, right? This can also be written as r, right? This can also be written as r. So we know these two results that we already discussed. So I can write this phi as r square into e power minus r, right? Because this is root of x square plus y square plus z square. So this is r square into e power minus r, right? I'm just changing in terms of r. Now we will find del phi now. So now we will find del phi. So del phi will be dou by dou x of r square e power minus r I vector dou by of r square e power minus r j vector dou by dou z of r square e power minus r into k vector, right? Now we will differentiate with respect to r and then we will put dou r by dou x. So we need to apply UV method. So UV. So first I'm giving r square as it is. So partial derivative of e power minus r is minus e power minus r. Now I'm keeping e power minus r as it is. R square is 2r into dou r by dou x, right? Into I vector. Because we are differentiating with respect to x, but here we have r. So r is a function of x, y, z. So you apply product rule and then you put dou r by dou x. Now similarly, same here also. So these term will remain as it is, right? These term will remain as it is here. We have dou r by dou y. So r square minus e power minus r plus e power minus r into 2r dou r by dou y j vector plus r square e power minus e power minus r into 2r dou r by dou z into k vector, right? Okay. Now I can take this e power minus r outside, right? So if I take e power minus r outside, here we have 2r, here we have minus r square. And what is dou r by dou x? We know it is x by r, right? We already solved this, right? Dou r by dou x is x by r, dou r by dou y is y by r. And here also if we take e power minus r outside, we have 2r minus r square into y by r. And if we take e power minus r square, if we take e power minus r outside, 2r minus r into y by r k vector, right? So we know this, right? Okay. Because we differentiate this with respect to x. So 2r dou r by dou x is 2x. This will be 0. So dou r by dou x will be x by r, right? Similarly, if you differentiate with respect to y, you can find dou r by dou y to be y by r. You already done this, right? You already done this. Now, if I can take e power minus r to 2r. I can take this entire term common. So e power minus r 2r by r square. If we take this entire term common, we have xi plus yj plus zk divided by r, right? Divided by r. Now I can take this 1r outside. I can cancel this 1r. Sorry. So this is e power minus r. So if I take 1r outside, so 2 minus r, and this is r vector divided by r. Make this r vector xi plus yj plus zk. So I can cancel this 1r. So e power minus r 2 minus r into r vector, right? E power minus r 2 minus r e power minus r. This is the required gradient for the given function, right? If you replace r to be xi plus yj plus zk, you will have a vector, right? So very simple problem, just to refresh. Now we are going to learn a new topic, right? Answer a new topic, we want a new set of problem. Y by r, z by r. Okay. Now the next thing is, if you given f, right? So given f, this f is a scalar point function. You can find gradient of f, right? you can find gradient of f. This is a vector point function, yes or no? So given a scalar point function f, you can find gradient of f, right? Using the formula dou f by dou x I vector, dou f by dou y j vector, dou f by dou z k vector, right? So given a scalar point function, you can find gradient of f. Now, given a vector point function, given a gradient function, can you find the given f? That is, they will give del phi, you need to find phi, right? Okay, rf, right? So they will give del f, you need to find f now. So they will give del f, you need to find f. Given f, you can easily find del f, right? So given f, you can easily find del f using the formula. Now they are going to given you the question, they are going to give you del f. Now you need to find f. That is the next set of problem we are going to do. Is it clear? If they given a scalar point function, you can find gradient very easily using this formula. Now they are going to give del f. You need to find f. That is the next set of problem, right? So they are going to give you a vector point function. You need to find a scalar point function, right? That has to be gradient of f, right? That is, you need, if you apply gradient to this, you have to get this. They will give this, right? They will give this. Right? They will give this. We need to find this, right? So we'll do some problems based on this. So clear, right? So given f, you can easily find del f. Now they are going to give you del f. You need to find f. Okay. First problem. So if you understand the first problem, you can do any problem, right? If del f is equal to y square I vector 2xy plus e power 3z j vector 3y e power 3z k vector, find f. Right? So they are given del f, that is a given vector point function. You need to find f, right? You have to listen this very carefully. So if you understand the first problem, then you can do the remaining problems, right? Yes. They have given del f, right? So they have given del f. Given del f. So del f is y square I vector 2xy plus e power 3z j vector 3y e power 3z k vector, right? This is what is the formula for del f? So it is dou f by dou x I vector, dou f by dou y j vector, dou f by dou z k vector. So when you compare this, so if you compare this, you will get dou f by dou x to be equal to y square, dou f by dou y to be equal to 2xy plus e power 3z, and dou f by dou z to be equal to 3y e power 3z, right? So you need to, I think the question is clear, right? You need to find a scalar point function whose gradient is this, right? So dou f by dou x is y square, dou f by dou y is 2xy plus e power 3z, dou f by dou z is 3y e power 3z, right? Okay. Now what you have to do is, you just take the first term, right? You just take this term. We have dou f by dou x to be equal to y square. So integrate with respect to x, right? Then only this dou by dou x will be vanished. So integrate with respect to x. Integrate with respect to x. So this will be, so I'm going to integrate with respect to x, dou f by dou x, and I'm going to integrate this with respect to x, right? Remember here f is a function of three variable x, y, z. So when you integrate this, this will be f, and if you integrate with respect to x, right? So it will be dx. So this will be x y square, because y square is constant. So integration of dx is x, plus we will have some function of yz. This is very important, right? Because this f is a function of x, y, z, normally if you have a function of single variable means you will put plus c, but here we have a function of three variable with respect to x means you need to put this as g of y comma z, right? Let's call this as equation number 1, right? So I'm just taking this function and I'm integrating with respect to x. So we have xy square plus, because there is no x term here, so there will be integration of dx, so which is x plus some function of g of y comma z, right? Now I'm going to differentiate this partially, right? So differentiate partially with respect to y. With respect to y. So we have dou f by dou y is equal to, dou f by dou y is equal to, once more, okay. So they are given del f, right? This is dou f by dou x, this is dou f by dou y, this is dou f by dou z. I'm taking this first term, dou f by dou x is y square. I'm integrating with respect to x. So this will be f. This will be, here there is no x term. So that means we will have only integral of dx. So y square x, some function of g of y comma z, right? So because we have f to be a function of x, y, z, we are integrating with respect to x. So we have some function of g of y comma z, right? Okay. Now I'm differentiating this with respect to y. So x will be constant, y square will be 2y, and this will be g dash of y comma z, right? Actually our aim is to find this g of y comma z, right? Okay. Now let us call this as 1, call this as 2, call this as 3, call this as some star, right? Okay. Now actually what I did is I have taken this term and I have integrated with respect to x, right? We have got this term. Our aim is to find this g of y comma z. For that, what I'm doing is I'm differentiating this with respect to y. So dou f by dou y is x into 2y plus g dash of y comma z, right? Now from 2 we know that dou f by dou y is 2xy plus e power 3z, right? So from 2 we know that dou f by dou y, let us call this as double star, 2xy plus e power 3z, right? So comparing 2 and a double star, comparing 2 and a double star, see we are differentiating with respect to y, so we have g dash of y comma z. Okay. So comparing 2 and double star, so we have this to be 2xy plus e power 3z, right? 2xy plus e power 3z is equal to, so here we have dou f by dou y. So I'm just comparing this and this, right? Here we have dou f by dou y, here we have dou f by dou y. So 2xy plus e power 3z is equal to 2xy plus g dash of y comma z, right? So if you cancel this, you will have g dash of y comma z is equal to e power 3z, right? G dash of y comma z is equal to e power 3z. Now I'm going to integrate with respect to y. This is the steps, right? Integrate with respect to y. You have to follow this for every problem, right? This is the same step you're going to follow for every problem. So we integrate with respect to y. So I'm going to integrate with respect to y. So g dash of y comma z, right? G dash of y comma z is equal to integration of y e power 3z dy. So this will be g of y comma z, and we are integrating with respect to y. So e power 3z is constant into y, plus we have some function of z, because g is a function of yz. So we are already integrating with respect to y. So z is remaining. So we have h of z. But here we have f to be a function of x, y, z. So we have put in y comma z here. But here g is a function of y and z only. So this constant will be h of y comma z. So we have found g of y comma z now, which is e power 3z into y plus h of z. Right? Let us call this as triple star. Now substitute in star, right? Substitute in star. So what is f? F is xy square plus g of y comma z. So this will be xy square plus g of y comma z is y into e power 3z plus h of z. Now we need to find h of z now, right? So if I find h of z, the problem will be over. So what I have did is I have taken this term, I have integrated with respect to x. So we have got g of y comma z. Our aim is to find g of y comma z. So for g of y comma z, you need to differentiate with respect to y, and you need to compare this and this. You need to compare this and this. You will get g dash of y comma z to be equal to some term. Integrate with respect to y, you will have g of y comma z. Right? Now we need to find h of z. So to find h of z, h of z, I'm going to differentiate with respect to z now, right? So this will be dou f by dou z is equal to, so if we differentiate with respect to z, this will be 0, and this will be e power 3z into 3 plus h dash of z, right? So that means dou f by dou z is 3y e power 3z plus h dash of z. Now you compare dou f by dou z with this dou f by dou z, right? So let's call this as some 4 star. So compare this 4 star with 3, right? So we already have dou f by dou z to be equal to 3y e power 3z. So but from here, from 4 star, we have 3y e power 3z plus h dash of z, right? So when you compare this, you will have 3y e power 3z is equal to 3y e power 3z plus h dash of z. So this implies h dash of z is 0. This implies h of z is constant, right? Here we don't have some functions, right? Because it's a function of single variable, so you don't need to put some plus some function of something, right? So h of z is c. So therefore the required function f is this is a required function. So from a the required function is xy square plus y into e power 3z plus h of z, which is c, right? This is the required function. You can check it very easily, right? You can check it very easily. So you can verify this very easily. So for verification, you just find del f for this. So it is dou f by dou x I vector, dou f by dou y j vector, dou f by dou z k vector. So what is dou x? What is dou f by dou x with respect to x, right? So this will be y square I vector with respect to y. So this will be 2xy plus e power 3z into j vector with respect to z. So this will be 3y e power 3z k vector, right? So again, this is a given question, right? Y square I vector plus 2xy plus e power 3z j vector, 3y e power 3z k vector, 3y e power 3z k vector. So our problem is correct. Our f is correct, right? This is the same method you need to follow for every problem. So I'll repeat. So you just compare. You just compare with gradient formula. You will get dou f by dou x, dou f by dou y, dou f by dou z. Take this first term, integrate with respect to x. So you will have some function of g of y comma z. Our aim is to find g of y comma z. To find g of y comma z, we need to integrate. You differentiate with respect to y, right? And then you compare with 2, right? You can see that there is the same trend, right? So for finding g, we are differentiating with respect to y and comparing this with 2. And here if we have h of z, means you differentiate with respect to z and compare with that, right? So dou f by dou y will be, you differentiate this with respect to y. So you will have this. Now you compare this and this. You will get g dash of y comma z is equal to e power 3z. Integrate with respect to y. This is very important. So if you integrate with respect to y, means g of y comma z will be e power 3z y plus h of z, right? Because we have g of y comma z, we are integrating with respect to y, means we have function of z. Now our aim is to find h of z. So differentiate with respect to y, with respect to z, and compare this with this. You will get h dash of z to be equal to 0. So that means h of z is c. So we have found g of y comma z and h of z. So substitute here. You will get the required f. Is it clear? So then move on to the next problem. Yes, now we will solve yeah, day before yesterday question paper, right? So in day before question paper, there is one problem based on this. Yes, now we'll solve this problem, right? E, to show that the vector A is irrotational and find phi if del phi is this. So they are given del phi, you need to find phi, right? So they are given del phi, you need to find phi, right? Okay, so first we need to show this is irrotational. So for irrotational, we need to show del cross A is 0 and we need to find phi such that del phi is this, right? So they are given del phi to be a vector, the same problem that we have done, right? Okay. So we'll do this. So first we need to show this irrotational. So we will find del cross A. So del cross A is I vector, J vector, K vector. So del is dou by dou x, dou by dou y, dou by dou z. 6xy plus z cube, 3x square minus z, 3x z square minus y. So expand this. So this will be I vector. So dou by dou y will be -1 minus dou by dou z will be -1 again, minus j into dou by dou x will be 3z square, dou by dou z will be again this is minus 3z square, plus k into dou by dou x is 6x minus dou by dou y will be again 6x. So this will be 0i plus 0j plus 0k, which is 0. So therefore, it is irrotational. Right? Now you need to find phi if del phi is given, right? The same as previous problem. So they have given del phi to be equal to del phi is A. What is A? It is 6xy 6xy plus z cube I vector 3x square minus z into j vector plus 3x z square minus y into k vector. So find phi, right? So find phi. So they're given gradient. You need to find the required. You need to find the corresponding scalar point function, right? Okay. Same as previous problem, right? So we know that del phi is. We know that del phi is dou f by dou x I vector. Okay. Dou f dou phi by dou x, right? Because we are using phi here. Dou phi by dou y j vector. Dou phi by dou z into k vector. So compare this. So comparing, we have dou phi by dou x equal to 6xy plus z cube. Dou phi by dou y to be equal to 3x square minus z. Dou phi by dou z to be equal to 3x z square minus y, right? So call this as 1, call this as 2, call this as 3. Now, what we did in the previous problem, we have taken this function, we have integrated with respect to x, right? So from 1 we have dou phi by dou x to be equal to 6xy plus z cube. So integrate with respect to x. So we will have phi to be equal to integration of 6xy plus z cube dx. So this will be 6y is constant. Integration of x is x squared by 2 and z cube into x. Plus we have some function of y comma z, right? G of y comma z. Because this p is a function of x, y, z, we are integrating with respect to x, right? So this will be 3x square y plus x z cube into g of y comma z, right? Our aim is to find g of y comma z. What we did in the previous problem, we have differentiated with respect to y and then need to compare this and this, right? So differentiate, let us call this as number 1. So differentiate with respect to y. So we have dou phi by dou y to be equal to, so 3x square, y is 1 and this will be 0 and this will be g dash of y comma z. Let us call this as 2. Now compare this 2 and 2, right? So compare this 2 and 2. So compare this 2 and 2. So from 2 we have dou phi by dou y to be equal to 3x square minus z. From Roman 2 we have dou phi by dou y to be equal to 3x square plus g dash of y comma z. So when you compare this, you will have g dash of y comma z is equal to minus z. What you need to do? Integrate with respect to y, right? So this will be g dash of y comma z with respect to y. With respect to y, right? So this will be g of y comma z to be equal to minus zy, some function of z, right? Because it is a function of y and z only. Now you substitute this g of y comma z. Let us call this as 3. Now substitute 3 in 1, right? So what is phi? Our phi is 3x square y plus xz cube plus g of y comma z. So we have found g of y comma z now. Xz cube minus yz plus h of z. Now we need to find h of z. For that, what we need to do? Differentiate with respect to z and compare this 3 and this, right? So differentiate with respect to z. So we have dou phi by dou z is equal to 0 plus x into 3z square minus y plus h dash of z, right? So this is 3xz square minus y plus h dash of z. Call this as some 4. Now compare 3x, compare this 3 and 4, right? So compare 3 and 4. So we already know dou phi by dou z is 3xz square minus y. From 4 we have dou phi by dou z to be 3xz square minus y plus h dash of z. So when you compare this, you will get h dash of z is equal to 0. That means h dash of z is constant, right? So therefore the required phi is, so you substitute this is the required phi. So a becomes, so phi is equal to 3x square y plus xz cube minus yz plus c. This is the required phi. Now you can check this, right? You can check this. So you just find gradient for this function. You will get this as answer, right? You can verify this. So you just find del phi. So del phi is dou phi by dou x I vector, dou phi by dou y j vector, dou phi by dou z k vector. So dou phi by dou x with respect to x. So this will be 6xy plus z cube into I vector. Now with respect to y, so this will be 3x square minus z j vector. With respect to z, 3xz square minus y k vector. This is the required given question, right? 6xy plus z cube I vector, 3x square minus z, 3x square minus z, 3xz square minus y, 3z square minus y. So therefore our phi is correct, right? This is the required phi. Is it clear? So from phi we can easily find del phi. So from del phi to phi you need to follow this method, right? Is it clear? You can do this in within 5 minutes if you have good practice, right? Actually, 5 minutes itself is very big. We can finish this in 2 to 3 minutes, right? Okay, find f of r if del f is r vector divided by r power 5 and f of 1 is 0, right? So here everything is in terms of r. So in the previous problem, they have given del f to be in Cartesian form, right? So xi plus yj plus zk, we have found the f. But here they have given del f in r, right? R vector is xi plus yj plus zk, r power 5. R power 5 will be, we know r is root of x square plus y square plus z square. So r power 5 will be x square plus y square plus z square whole power 5 by 2. So actually you can do this in two method, but the first method will take so much of time. For example, if you try to convert this to xi plus yj plus zk, right? Usually how we will do? Usually we will have something into I vector, something into j, something into k. Suppose if you try to convert this to xi plus yj plus zk, because r is xi plus yj plus zk, and this will be x square plus y square plus z square whole power 5 by 2, right? Because r is x square plus y square plus z square whole power 1 by 2. So if you take whole r power 5 will be r power, this will be 5 by 2. Now you can individually divide this term with this. So x square plus y square plus z square whole power 5 by 2 into I plus y divided by x square plus y square plus z square whole power 5 by 2 into j plus z divided by x square plus y square plus z square whole power 5 by 2 into k. Now this will take so much of time, right? This is dou f by dou x, this is dou f by dou y, this is dou f by dou z. It is not that easy to differentiate this with respect to x and integrate it. It will take so much of time. So instead of this, I'm going to follow the different method now. So if you have in terms of r, you don't follow this method, right? Actually, you can follow, but it will take so much of time. You try to do this problem, right? But I'm going to follow a different method now, right? You try to do this method, right? You'll get the same answer only. And also, if you go by this method, you will have a function of x, y, z. But we need to find in terms of r, right? And then we need to convert this in terms of r. After finding in terms of x, y, z, we need to convert in terms of r. It takes so much of time. So what I'm going to do is we're going to follow different method now. So we need to find f such that del f is r vector by r power 5, right? Solution. Okay. Now they have given del of f of r, right? F is a function of r is equal to r vector by r power 5. Now what is del? So del is dou by dou x of I vector, dou by dou y of j vector, dou by dou z of k vector into f of r is equal to r vector by r power 5, right? So this is nothing but dou by dou x of f of r into I vector, dou by dou y of f of r into j vector, dou by dou z of f of r into k vector is equal to r vector by r power 5, right? So what is dou by dou x of this is f dash of r into dou r by dou x I vector, and this is f dash of r dou r by dou y into j vector, f dash of r dou r by dou z into j vector is equal to r vector by r power 5. So we know dou r by dou x is x by r. So I can take this f dash of r outside. And this is x by r I vector. This is y by r. And this is y by r j vector. This is z by r. This is k. Z by r k vector is equal to r vector by r power 5, right? So we know r square is x square plus y square plus z square. So 2r by dou x is 2x. So this implies dou r by dou x is x by r, and similarly dou r by dou y is y by r, dou r by dou z is z by r, right? We already know this with respect to x, with respect to y, with respect to z. Now f dash of r, so we take this 1 by r outside, we have xi plus yj plus zk is equal to r vector by r power 5. So this r vector and this will get cancelled, right? Because r vector is xi plus yj plus zk, and this 1r will get cancelled. So we have f dash of r. So we have f dash of r to be equal to 1 divided by r power 4, right? So this r will get cancelled. So we have f dash of r to be 1 by r4. Now integrate with respect to r, you can easily find f of r. So integrate with respect to r. So integration of f dash of r, integration of 1 by r power 4 dr. This is f of r. This is f of r. So integration of r power minus 4 dr, and this will be r power minus 4 plus 1 by minus 4 plus 1, some integration constant c. So we have f of r to be equal to r power minus 3 by minus 3 plus c. So this implies f of r is minus 1 by 3 r power 3 minus 1 by 3 r power 3 plus c. This is the f of r. To find this integration constant, they have given that f of 1 is 0, right? So they have given f of 1 is 0. So you just put f of 1 to be equal to 0. So minus 1 by 3 plus c is equal to 0. This implies c is equal to 1 by 3. So therefore f of r, so f of r is minus 1 by 3 r power 3 plus 1 by 3. This is the required f of r. Minus 1 by 3 r power 3 plus 1 by 3. Is it clear? So instead of converting this to Cartesian and then converting back to in terms of r means it take time. So we are doing like this, right? And I'll give you some exercise problems, right? I'll give you some exercise problem. So find the value of lambda and mu so that the surfaces lambda z square, sorry, lambda x square minus mu into yz is equal to lambda plus 2 into x and 4x square y plus z cube is equal to 4 may intersect orthogonally at 1 comma minus 1 comma 2. Very simple, right? So we need to find the angle between the surface. They are given the angle between them is 90 degree, right? They are given that angle between these two surfaces is 90 degree because it intersects orthogonally. So they are given that angle between them is 90 degree, right? So angle between them is 90 degree. So we know angle between the two surfaces, right? So angle between two surfaces is equal to cos theta is equal to del phi1 into del phi2 at the point 1 comma minus 1 comma 2 divided by modulus of del phi1 into modulus of del phi2. So lambda x square minus mu into yz is equal to lambda plus 2 into x, right? Lambda plus 2 into x, lambda plus 2 into x. Okay, so given we know this formula. So here theta is equal to 90 degree. So therefore cos 90 is equal to del phi1 dot del phi2 divided by modulus of del phi1 modulus of del phi2. This is at the point 1 comma minus 1 comma 2. So we know cos 90 is 0, right? So cos 90 is 0. So we have 0 is equal to del phi1 dot del phi2 divided by modulus of del phi1 modulus of del phi2. Now this implies del phi1 dot del phi2 is 0, right? Because denominator should not be 0, right? You are getting this term to be equal to 0 means numerator has to be 0 at the point 1 comma minus 1 comma 2. So just find del phi1 and del phi2 at this point, make a dot product, you will get the required answer. Okay, so we have what is our first surface phi1. So it is lambda x square minus mu into yz is equal minus lambda plus 2 into x, right? Minus lambda plus 2 into x. So we will find del phi1. So del phi1 is dou phi1 by dou x I vector, dou phi1 by dou y j vector, dou phi1 by dou z k vector. Now differentiate with respect to x. So this will be lambda into 2x. This will be 0 and this will be minus of lambda plus 2 into I vector. With respect to y, this will be 0. This will be minus mu z. This will be 0 into j vector plus with respect to z, this will be 0. This will be minus mu y into k vector. Now you find at the point 1 comma minus 1 comma 2. This is x, y, z. So x is 1. So 2 lambda minus lambda plus 2 into I vector minus mu into z is 2 into j vector minus mu into y is minus 1 into k vector. So 2 lambda minus lambda is lambda. So we have lambda minus 2 I vector minus 2 times mu j vector plus mu into k vector. This is del phi1 at this point. Now you find del phi2 at the same point again. Now what is phi2? Now phi2 is 4x square y plus z cube minus 4. Now you find del phi2. Very simple, right? So they are given that angle between them is 90 degree. So this is dou phi2 by dou x I vector, dou phi2 by dou y j vector, dou phi2 by dou z k vector. Now with respect to x, so this will be 8xy I vector. With respect to y, so this will be 4x square j vector. With respect to z, this will be 0. This will be 3z square k vector. Now at the point 1 comma minus 1 comma 2, so 8x into y I vector plus 4x square j vector 3z square k vector. So this will be minus 8i vector plus 4j vector. 2 square is 4. 2 square is 4. 4 3s are 12. And this will be 12k vector, right? Now substitute back in A, right? From A, you can use anything, right? I am comfortable with I vector. Okay. Del phi1 dot del phi2 is equal to 0, right? We know this is 0 at the point 1 comma minus 1 comma 2. Now what is del phi1 at this point? So it is lambda minus 2 into I vector minus 2 mu j vector plus mu into k vector dot Del phi2 at this point is minus 8i plus 4j plus 12k. So make a dot product. So minus 8 into lambda minus 2 is equal to 0. This is same as 0i plus 0j plus 0k. Just make a dot product and equal to 0. So minus 8 into lambda minus 2 minus 2 mu into 4. Yeah. You just have to make a dot product now, right? So this will be minus 8 into lambda minus 2 minus 8 into lambda minus 2 minus 8 mu plus 12 mu is equal to 0, right? Plus 12 mu is equal to 0. So that means minus 8 lambda. I can also take this 4 out. I can take 4 outside and minus 8 lambda. Okay, minus 8 lambda plus 16 minus 8 mu plus 12 mu is equal to 0. Minus 8 lambda, 12 mu minus 8 mu is 4 mu is equal to minus 16. So if you divide by 4, minus 2 lambda plus mu is equal to minus 4, right? Minus 2 lambda minus 2 lambda is equal to minus 4. Yes. So this is the relation between and minus 2 lambda plus mu is equal to minus 4, right? This is the relation between lambda and mu. Now this is angle between the two surfaces, right? Okay. Now you just substitute okay, now you just substitute the point at 1 comma minus 1 comma it lies on star, right? Because it is on surface, right? Just substitute this point 1 minus 1 2, right? 1 minus 1 2 1 minus 1 2. So we have alpha minus 2 times lambda plus mu is equal to minus 4. No. Actually, this wait. Okay, this is the angle between the surfaces. Okay. Now we need to find lambda and mu, right? We need to find lambda and mu exactly. Now what we can do is this angle between the surfaces. Okay, we can go by this approach, right? So we know two surfaces, right? Now first surface is lambda x square minus mu into yz minus lambda plus 2x. This is the first surface, right? Okay. Now second surface is phi2. Phi2 is 4x square y plus z cube minus 4. We know these two surfaces, and we know this point will lie on both the surfaces, right? Because it intersecting orthogonally. So this 1 minus 1 2 lies on both the surfaces, right? Now that means it will satisfy this equation. So at 1 minus 1 2, so phi of this phi1 is a function of xyz. So phi1 of this point will be 0, and again phi2 of 1 minus 2 will be 0, because 1 minus 1 2 lies on the surface p1 and p2. Now substitute this point and equal to 0. So lambda into 1 square mu into yz lambda plus 2 into x is 0. So we have lambda minus 2 mu minus lambda minus 2 is equal to 0. We are getting mu to be equal to 1, right? Minus 2 mu is equal to 2. Okay, this is yz, sorry. This minus should be plus. So that means mu is equal to 1, right? That means mu is equal to 1. And okay, let us keep this as it is, right? So we have found mu is equal to 1. And from star, we know minus 2 lambda plus mu is equal to minus 4. So mu is 1 is equal to minus 4. So minus 2 lambda is equal to minus 4 minus 1 is minus 5. So lambda is equal to 5 by 2. So lambda is 5 by 2 and the mu is 1, right? So is it clear? Very simple. So you just have to make del phi1 and del phi2 dot 0 at 1 minus 1 2. You will have a relation between lambda and mu. You need to find lambda and mu exactly. So for that, this point lie on both the surfaces. So if you make use of that, you will get mu to be equal to 1. Substitute that mu here, you will get lambda. So therefore, this is the required lambda and mu, so that the surfaces are may intersect orthogonally at the point 1 minus 1 2. Is it clear? So we'll do last problem and then we'll wind off. Right. So you take the first part, so verify whether f is irrotational or not, right? You can do this very easily. So it will be irrotational, right? It will be irrotational. So this is 0 k vector, right? 0 k vector. Okay. Now you need to find scalar potential. That is nothing but you need to find scalar function for the given vector point function. That is, you need to find, they are given del f, you need to find f, right? So we have del cross f to be equal to 0, right? Verify. This will be 0. So it is irrotational. Now you need to find scalar potential. That is, you need to find f if del f is this, right? If del f is this. If del f is x square plus xy square I vector y square plus xy square j vector, right? You need to find this f, right? Okay, so you need to find f. Okay, so I think you can do this, right? So they are given del f, you need to find f. So we have del f is x square plus x y square I vector y square plus xy square j vector plus 0 k vector, right? Actually, you can think as a function of ij only, right? So this implies dou f by dou x is x square plus xy square. Dou f by dou y is y square plus x square y, and dou f by dou z is 0, right? So f is 0. Okay. So you just take this and integrate with respect to x, right? So integrate with respect to x. So this will be integration of dou f by dou x with respect to x, integration of x with respect to x. So this will be x cube by 3 plus y square x square by 2. Some function of, I'm writing only g of y because z is 0, right? Z is 0. Usually you write g of y comma z. I'm writing g of y alone, right? Okay. Now, so this is our f now. So f is x cube by 3 x square y square by 2 plus g of y, right? Now differentiate with respect to y and compare this and this. So differentiate with respect to y. So we have dou f by dou y is equal to, this will be 0 and x square by 2 is constant. This is 2y and this is g dash of y, right? So compare with the 2. So call this as 1, call this as 2. So compare with the 2. Okay, with respect to x means x cube by 3 y square by 2 plus g of y. Okay, so when you compare this, we have dou f by dou y. We have dou f by dou y is y square plus x square y. So when you compare this, we will have this 2 will get cancelled. So x square y plus g dash of y is equal to y square plus x square y. This implies g dash of y is y square. So g of y will be integration of y square dy. So you don't need to put, you don't need to put h of z because it is function of 2 ij only. So that means g of y is y cube by 3, right? If you want, you can put some constant c. So therefore, the function f is x cube by 3 plus x square y square by 2 plus g of y is y cube by 3 plus c. This is the required scalar potential. X cube by 3. Is it clear? So if you want, you can find gradient for this function. You will get this as an answer, right? So that's it. So I have briefly covered the gradient, divergence, and curl. So in the Telegram group, I will give you the last 20 years questions of gradient, divergence, and curl, right? I'll compile and give you topic wise. You try to do all the problem. I think you can do all the problem, right? I'm going to give you last 20 years problems from UPSC that is based on gradient, divergence, and curl, right? I'll give you that. So you just practice that. I think you can do all the problem, right? If you have watched this 6 lectures. So that's it. So in the next class, we're going to start a line integral, surface integral, volume integral. Actually, we need to start curvature, torsion, and Faraday formula, but we are doing line integral, surface integral, volume integral in the next class, right? So thank you, bye.